For today's video, we are going to be talking about an algebraic equation. So we have a situation here. It says Sam can run 5 meters per second and Malik can run 7 meters per second. So right now what we know is that Malik can run 2 meters further every second. But in this situation, if Sam is given a 10-meter head start, who will finish the 60-meter race first? So we need to understand, this is a coordinate grid. And what we know is this is called our x-axis, which is labeled time, and it's seconds. So every 1 is a second. Up here, this is our y-axis, and this is how far they've traveled. And again, the goal is to make a 60-meter race. So the first one to reach 60 is going to be the winner. So that's what we have to figure out. But before we can do anything, we have to know, we have 2 different equations. I know that Sam can run 5 meters per second. Now, seconds are our x, because that's our x-axis. And then I know that Malik is 7 meters per second. So right now, here's our situation. Every time I plug in 1 second, Sam goes 5 meters. Every time I plug in 1 second, Malik goes 7 meters. But then it says if Sam is given a 10-meter head start, I need to take into account that Sam is starting with a 10-meter head start. So at 1 second, Sam isn't just going to be at 10 meters. That's where he's starting. So we know that I plug in 1. 5 times 1 is, everybody?
5.
Plus 10, Sam is going to be at 15 meters. If I plug in 2, 2 times 5 is 10, plus 10, Sam is going to be at 20 meters. 25 meters. And every second that goes, we're going to gain 5 meters in distance. So we see that we are creating a linear equation, a line basically. So how long did it take for Sam to finish this race? What do we see? How many seconds did it take for Sam to reach 60 meters? Aaron?
11.
It took him 11 seconds, 10 seconds.
Oh.
It's kind of hard to read.
11.
It takes 10 seconds right here
Oh, yeah.
to meet 60 meters. And we find that by using our highlighter tool. We'll just highlight where did this graph meet 60. And it's right at 10 seconds. So I know now that Sam was 60 seconds when this was x was 10. Plugged in 10, I get out 60. Well, Malik, at 1 second, he's only at 7. Because Malik started at 0. He started at 0, 0. He didn't get any head start. Then at 2 seconds, 7 times 2,
12. 14.
he's going to be at 14. So he's now at 14 seconds. 7 times now 3 seconds.
21.
He's going to be at 21 seconds. 21 meters. Correct. At 4 seconds, 7 times 4?
28.
28 meters. So what do you notice is happening to the distance between the two? Blake? It's getting closer. So who's catching up? Malik.
Me.
You are, Malik. So Malik is catching up to Sam. And finally, at 5 seconds, they're tied. Because 7 times 5 is 35. This is where they intersect. They're crossing each other's path. At 6 seconds, Malik pulls ahead. He's now at 42 meters. At 7, he's at 49. At 8, he's at 56. And then at 9, he's going to be at 63, which tells us what? If he's at 63, what did he do? He won the race. He crossed the finish line. So if we look here, Malik, I'll make his line, started at 0-0. He didn't get any head start. But if we keep going, he's going to reach 63 meters in 9 seconds. So he's going to actually win the race by 1 second. This is graphing linear equations based on what we know. This is not easy stuff. But what we have to understand is we have an x that we plug in and we get out a y.